Good afternoon, I'm Brandon Massoni. I'll be talking about additive manufacturing applications in our lecture 17. To start with, I have a picture of this Boeing airplane, which is produced with, Airbus airplane. 1,000 3D printed parts on it. Some of these parts are titanium, and most of them are plastic. But I'm going to talk about some of the titanium parts, some of the ones that are in this airplane, and some of that are on other aircraft. So the first one I'm going to look at is GE Aviation. They make big commercial jet engines, and they're based out of Cincinnati, Ohio, and they have 44,000 employees-ish. So that's just a picture of one of the engines they make. And so they had a contest recently on GrabCAD to redesign a engine handling bracket, so something that would hold that engine similar to something like the one on the previous slide. And they had some printing parameters that they set. They said it was going to be direct metal laser sintered. It was going to be out of this titanium 6AL4V, and it had a minimum wall thickness of 0.05 inches. And they had over 600, 700 designs that made it to them. And then they selected the 10 best via testing before printing. They were able to do some of that. And then out of the 10 best parts, this one shown here was the best out of actual testing. So I guess one of the interesting things about this is it actually went through quite a bit of rigorous testing in comparison with a bunch of other similar designs to create the most optimal design that they could come up with. And so this titanium part has axle loads up to 9,500 pounds, torque load of 500 inch-pounds, and it's an 84% weight reduction from its predecessor. So that's 4.48 pounds to 0.72 pounds. And so this is similar to like this whole design or idea of redesigning parts in making use of additive manufacturing is something that's not always thought of. It's not just that you can make parts additively manufactured, but you can make different stuff now. This isn't topology optimized, but it was structurally optimized in some way through a bunch of 700 people iterating on it. But the next one I'll show is topology optimized. So this is Airbus. They're based out of France. They have 58,000 employees, so a few more than GE. And they've been working on brackets since they're not critical to the flight. So this is on the A350 XWB, the plane that was shown there. This is a bracket that was on there, and this has been topology optimized. You'll see it's like organic structures, or shape optimization is another way to think of it. It redirects you position the material where the loading is, and so in that way the material is only where it really needs to be, and you can get much lighter parts with this. So here's two brackets that they did, and the printing parameters are for this one on the left, and the next slide will be on this one on the left. The one on the bottom is just a common example that I've seen. So this is direct metal laser melting, again, titanium 6AL4V, which is the most common titanium in aerospace. And so this physical properties, this one had a 30% weight reduction over that part, so not quite as much as the other one. So some of the important system descriptions here is it's not a mission critical component. And that's because it has to go through a bunch of FEA tests, and it has to be approved, and all the sorts of validation that it needs to go through for a printed part to become a part of an airplane. So they've started with non-mission critical parts. This was originally milled from aluminum, so that's what it shows there. That's milled from aluminum, and now it's with titanium. So Now you can have these topology optimized organic shapes. And so the benefits, 90% less waste, weight reduction by 30%. This had some cost reduction. They didn't say what it was, but they said it reduced cost. So I'm assuming it's not by much. The big impact here is that with a weight reduction, it'll increase productivity of the airplane, and they can sell it for more because it's more fuel efficient. And it has a shortened lead time by up to 75%. So those are a few key factors of the Airbus brackets that are starting to introduce themselves into the industry. So these are some of the resources I have for that.